Then hi and welcome to the session about 12-factor cloud-native Java EE. My name is Sebastian Daschner. I'm a consultant and freelancer based in Germany, based in Munich. And well, I do all kind of Java-related things, enterprise-related things. I'm a consultant, a trainer, and also an author because I recently just wrote a book on pretty much that topic, how to architect modern Java EE applications, modern as in applications that are, well, lightweight, business-oriented and run on cloud and container technology and using, well, the latest Java EE standards. And while I do all kind of Java things, I am proud that I can help to evolve the future of Java Enterprise and expert groups and so on and so forth. So I'm happy that I can be here. It's quite interesting. So actually yesterday, it's interesting that I had more attendees in yesterday's sessions because this is the fun session. It's going to be live coding only. So all the time you have one last slide. There's of course a marketing slides about myself. So I'm doing all kind of things, consultation, workshops, trainings about topics like this, enterprise application development, and so on and so forth. So who cares? Now let's code something. Who of you has heard the term cloud native before? Hands up. Okay, quite a few. That's good. So we don't have too much time for introduction. So just briefly, 12-factor and cloud native. 12-factor applications are, well, basically 12 principles and methodologies how to develop modern so-called web apps, modern software as a service applications. We go through a few things. Second thing is cloud native. This is basically a term, well, how to build applications that are built for cloud technology and not necessarily cloud as in cloud platforms such as Amazon or Google Cloud, but more about the runtimes, about the environments. For example, there is the Cloud Native Computing Foundation as part of the Linux Foundation, and it includes projects, open source projects such as Kubernetes and, well, container runtimes, Prometheus, and so on and so forth that, well, we will use because I will show how to build Java EE applications that run in Kubernetes, that are orchestrated by our Kubernetes orchestration framework. Who of you has heard of Kubernetes? Hands up. Okay, most of you, that's very good. So we will use Kubernetes and Docker. And we will live code right now 2 applications. Why 2? Because 1 is boring, and we want to have 2 applications that communicate with each other, that both are orchestrated in a container orchestration framework. And the first one is called Hello Øredev. That is basically a Hello World application. And then we will have a second application later on that also does some stuff. And the first one, well, calls the second one. So basically what we have here, we have a Maven project that builds our application using the Java EE API. And I will tell later on that this is quite important. So this is our only dependency that we have, which is provided. So it doesn't end up in our deployment artifact. That means we want to have thin deployment artifacts because that makes a lot of sense using this new cloud native technology, for example, Docker and Prometheus. And what I will live code right now is, well, first of all, hello world, right? We always need hello world. I will do this over HTTP. So basically, I will include an HTTP REST resource that says, well, hello, right? This project is basically empty. That is the only class that is there already. I will use JAX-RS. That is the Java standard to write REST endpoints. And that is the well, bootstrap class that we need under the /resources path. That will just bootstrap our JAX-RS thing, but we don't need actually this. So just, well, let's start. Who of you is familiar with JAX-RS? Hands up. Okay, a lot of you. That's good. So basically, well, for now, this is quite boring. We just say hello, right? And no, let's do this properly. And that's it. And of course, well, boring stuff for now. So this is just hello world over REST, nothing new. And this is a, well, simple Java 7 application. So what we could do, we just build it using Maven. That is quite old. We have now a thin WAR file. Having these classes, yeah, boring. Now what do we want to have to run this thing on a cloud native technology on our Kubernetes cluster? Well, first of all, if you know, Kubernetes is based on Docker containers. So basically, we need a Docker container, right? Because I could take this WAR file now and install it on a locally installed application server like we have always done. But, well, first of all, I have to download that application server, and that's annoying. And we have to download it on our runtime in production, and that's also annoying. So let's do something else. We, well, Dockerize our project. And besides I'm German, I'm actually lazy, so I'm too lazy to write Docker files all over again, so I basically just generate one that, well, doesn't add much. So what we have, we take a base image, because that's always what happens with Docker files that we use to build Docker images. I here use Tommy, because it's a very nice and fast application server, Tommy 8. That already, well, includes Tommy and Java, so everything we need to run that application. And then I only need to add my thin WAR file, my WAR file that only includes, well, the business code, my hello world, basically. I copied that into the web apps directory, so it's an auto-deployment directory. So basically, once I start up a Docker container from that image, then it automatically deploys and runs my application. That's it. I now say Docker build. Docker build this image into, well, some image. I will use a locally running Docker registry. Why? Because, well, my Kubernetes cluster will have to pull it from somewhere, right? So this is why I build and push it with that name. So then it immediately goes there. Always be explicit with your Docker tags and your version of your Docker images. Version 1. Take the current directory and, well, build it. It's super fast. Why? Because the WAR file is actually very small, because we use, well, a thin deployment artifact. This is, well, 4 kilobyte in size, right? It only contains our business logic. Build it and actually also push it. And then now it pushes to the locally running registry. And then, well, we could run it, right? Docker run this thing from localhost. It's called hello Øredev version 1. And now I could run it with an exposed port and something like this, right? That's, well, doable, but also quite boring, because now it only runs locally. It's now done and start up. But actually, I want to run it in my Kubernetes cluster, right? Now I have a Docker image, which I could start up. That's already quite nice. So I could go now to production, download the same image, start it up in the same way, and then it runs. But, you know, I want to have networking. I maybe want to have several versions. What's about hot deployment and zero downtime? And Docker doesn't do all these things. I could add some, well, other stuff on top. And now I could also, well, use some sophisticated technology, some standard technologies such as Kubernetes. So basically what I have instead, I have a Kubernetes cluster running locally here on my laptop. Well, cluster, it's a mini kube cluster, so it only has one node, but actually there's no difference in using it. So it runs with, well, there's nothing running there, it's basically empty. So there's no pod and no service running. I will explain in a second what that is. So basically that's an empty cluster for now, and now we want to run that Docker image, right? We want to run that Hello World application. So basically what we want to do is, where's my project? What we want to do is we want to include, well, some specification to tell Kubernetes how to run this. Why? Because we care about these things that are called infrastructure as code. Why? Everything I want to define how my software looks like, what defines my software, and not only from the business code, from the code, the source code I write, but also from the runtime and the configuration. I want to specify all this in my project as code, right? This is what I'm doing in the Docker files. I specify everything I need to run my project with that application server in that version, with Java in that version, and I test this specific image, because then I am sure that it works. Because if I say, oh, just take whatever Java, and then, you know, Java 9 comes out or something else, and then your application breaks, no, this is bad. Always be explicit in your versions. And this is what we're doing here. We specify this as code, then it's all there in our version control project, and we now do the same with Kubernetes. So basically, we're specifying Kubernetes how our workload, well, should be treated in production. So basically, I'll create a directory here so it's easier. It's called deployment or whatever. And now we do a similar thing for Kubernetes. Kubernetes uses so-called YAML files to specify how that looks like. Who of you knows about YAML files? Hands up. Who of you likes YAML files? Hands up. Yeah, I know. I also don't like them that much. Or I wouldn't say I don't like them, but it's quite easy to get confused with, you know, the intonation if you get that wrong, and JSON is easier. But more or less the world has agreed upon using YAML for Kubernetes, so whatever, let's use this. And now what we want to have is, well, first of all, a service. What is a Kubernetes service? It's basically a logical abstraction over anything that runs. So everything we want to specify as a workload, in the broadest term, like an application server with an application, like a proxy server, like a database, is encapsulated and abstracted in a service. So we say we want to have a service, hello Øredev, basically. And then, of course, that is only an empty shell. There's nothing running there. We want to actually have a running container that is included in a so-called pod, right? So we have a Kubernetes pod then that runs our application. Anyway, let's first include a service. That is quite straightforward. We call it hello Øredev. It will expose a port, and we already know that this port is, well, 8080, because that's the standard port from Tommy. We could change that, but whatever. And now I can have, well, one pod. One pod is a bad idea because, well, one pod is basically one or more, but normally one running container. So normally one pod equals one container. But what if, you know, I want to scale up? What if I want to replace that container with a newer version? So basically, I don't use pods directly. I use another abstraction that is called deployment. And deployment, well, deploys pods. And I can use this deployment to redeploy new versions, to scale up, to scale down, and so on and so forth. So we call this the same name, hello Øredev, and it will use some image that is, well, the image we just built, hello Øredev version 1. And we can run this, right? And you already see some things like replica, build up my pods from this template. So every time you start up something, use this specification. And we will also include some so-called live as probes. Probes are a thing that, well, basically tells Kubernetes whether our application is ready to serve some traffic, right? Because once you start up a container, then, you know, with the JVM takes some time until it's up and running. The application server takes 1 or 2 seconds until it's up and running, and only then you can direct traffic. Otherwise, you will have some downtime. So these probes are basically a way to tell Kubernetes, now this container is ready to serve some traffic. And the liveness probe basically tells whether the container itself is, well, alive, whether there's the process running. And the readiness probe is now the business term, like now it's actually ready to serve some traffic. Now please direct some traffic upon it. We can basically use all kind of things, HTTP probes, because we will know that we will have something running there under resources hello, and basically every HTTP OK response tells us, okay, it's fine, it's now ready to serve some traffic. And that's about it. And now we can use this to, well, apply it to our Kubernetes cluster. So now we're creating resources for this service and deployment to, well, please apply everything that is in that YAML file, because we did it as code. And that's, I pushed it, I built the image, yeah, that should work. So it tells you service and deployment has been created. So now what you can have a look at, first of all, you get a service. So now you have a new service, hello Øredev, exposed via a port, that's nice. And we also have a pod that is running here, hello Øredev, this and that, has a cryptical name because, well, it's just a name that is been chosen by Kubernetes. And before it was just running, and now it's also, you see the difference, also ready to serve some traffic. Nice. So now we can actually connect to our cluster, and we connect that using the cluster IP. This is specific to my Minikube installation because, you know, it's running locally here in my laptop. I could also add some DNS if I do that locally and so on and so forth, but this basically ends up at my service. You see the service port that is exposed externally to the cluster. And now I can use the hello Øredev application resources hello to say hello from Øredev, right? And this is now basically my application running in a Kubernetes cluster. deployed with all that specification that we specify in our application here. So now that's, well, nice. We can run the same hello world example in Kubernetes. But now actually we want to have some communication, right? So now we want to see, that's boring. We want to communicate with something in our cluster, because that's the interesting part, how we do networking, how we resolve other things, how we do deployments. So let's now do the second application, same story. Øredev greetings, like it processes greetings. So basically we can ask the first application to give us a specific greeting, and that greeting is calculated by the second microservice that, you know, they communicate with each other over, for example, HTTP. So just to showcase that, it's the same thing basically. The Øredev greetings artifact here, it's also Maven Project. Same story, Java EE only, and also an empty project. Now let's say we will have some greetings resource. That is also a JAX-RS resource, right? Path greetings. So basically the first application will access this resource to, well, calculate some greetings. Let's say we will have also a resource that's a calculate greeting from, for example, a path. So greeting slash something. That something can be a variable, that is JAX-RS code for a name. So when you call greeting slash something, then, well, you return that something, and we can inject that given path parameter in our method, right? And then we basically, since this is a Java EE environment, can inject some managed bean, for example, a greeting processor that, well, processes and calculates our specific greetings. Greeting processor, calculate greeting, and I just saw that I cannot spell calculate, right? Yeah. And let's include this class as well. So this will be a managed bean that will include that method, and it has the highly sophisticated business logic, hello plus name. Let's do this as a microservice, of course. So that's basically it. It's also more or less hello world application that generates something for us. But now the interesting thing is, well, we also want to Dockerize that to include that WAR file that I'm building right now. So we built the same thing into an Øredev greetings WAR file that will be that application. And we can now, well, this is just my script to be less, to be lazy. Same story as before with a different WAR file, right? Again, we can now Docker build this into localhost Øredev greetings. Also with the version 1. We build it. It's again very fast. Why? Because we use Java EE. And with Java EE, we can have thin deployment artifacts. We don't ship any runtime in our WAR file. The WAR file is super small. And therefore, it's, well, super fast to build and push it. This is, of course, just locally, but also over a network, you're always just pushing the last layer. Docker uses a so-called copy on write file system, which is really good for our purposes, because it doesn't push the, whatever, how big that is, the 300 megabyte of our image. No, because that is the Tommy, and, you know, Java, that is huge. We don't push that each and every time. We just push our business application. We don't want to push any framework implementation. We don't have a fat standalone jar. That's a bad idea with Docker images. Why? Because we can use this copy on write file system approach to have a thin layer in our application. We only ship our class files. If you look at the target, the WAR file here, you will see it only includes our classes that we built. Nothing else. No Java EE specific things, no framework, no nothing. We just want to add our application and ship that each and every time, because then, well, the continuous delivery pipeline steps will be fast, right? Well, now let's include this as well. So what we need here, we also need the YAML specification to run this on Kubernetes, right? So again, same story. I built up a deployment folder, and I say Øredev greetings. That is now the other application. Now actually, same story as before. Øredev greetings, with same port, since it's also a Tommy running. And again, we also want to have that deployment to deploy what we just did, which is the Øredev greetings image in version 1. We can do the live probes as well, but now for the demo, we can also just leave them out. It starts up quite fast. So same story again. Now we build it, we push it, and we can apply it to our Kubernetes cluster. Deployment with our YAML file, and then it says the new service Øredev greetings and the equally named deployment has been created. And once we look to that, well, great, now we can access it. That means we can also, since it's exposed, externally test it, which now should our application do. Sorry, that is the wrong port I just saw. With the Øredev greetings service, and we have the Øredev greetings application, resources, greetings, let's say hello Duke, and it tells us hello Duke or hello Sweden, right? And that's it. Well, same story as before, nothing else, right? Actually, now we want to access that application from our first application, and now it gets a little bit more interesting. So basically, we want to include a second resource here that does a similar thing. We want to say, give us something back that, well, also returns a string from a first application, which will internally ask the second application. So let's say hello for a specific name. Same story as before, a path parameter with a name. And that now, well, let's include a managed bean now. Now it's also becoming more sophisticated. Greetings, and we will outsource this. Greetings, hello, and here the greetings, hello name, hello for a name, and we will include this. Hello without a name and hello with a name. And the second one will now call, well, our second application. So basically we'll include here another managed bean, for example, a greeting processor. Now we're in the first application, and that will access our second application, right? So basically we can say greetings processor calculate greeting for the name, and that internally will ask our second application via HTTP, right? So that's it. And now what we need here is, well, an HTTP client, right? And luckily Java EE ships with a sophisticated HTTP client also from JAX-RS. We can use JAX-RS from the client side that, well, inits and builds a client builder, new client. And now with the target method, well, we access something, right? HTTP, well, now the question is, what do we access? Because that is quite interesting. We don't want to include an IP here. IPs are a bad idea that can change. We could use some configuration and then some configuration file that changes, but that's also a bad idea because why? I told you before, we want to be specific in versions. That means we want to build something once and test it and use it everywhere. We build an application once, no matter whether it's a jar file or a WAR file or a Docker image, including everything, and we test that specific image, and then we want to shift that specific image to production and don't change it, because every change, well, can introduce some break. That means we don't want to configure here anything. That means, well, what could we use? If we include an IP, we could use an external file and then inject it to the Docker container. That's possible. Or, well, we actually have something that we can just use. We can just use the logical service name. Øredev greetings here, port 8080. Why? Kubernetes internally uses a DNS resolving to resolve these services. So basically we can access services on our running pods internally in the cluster, right? So here we specify Øredev greetings, that name, that exposes the port 8080, and we can use that here in our first application to access this thing. Øredev greetings, resource greetings, And that's the target that we will use. And then we don't have to configure anything else. Because if we now in this local environment, it will have an Øredev greeting service. If we are in staging somewhere, we will have the same service. If we are in production, we will also have the same service. It always has the same name, therefore we don't have to change the code. We can hard code that here. And then, well, you know, you can just request something here, request a string .get, and read it as a string class, and so on and so forth. And then always close your resources on application server shutdown. And that's basically it. We can use this as is and read that resource here. Of course, if you look more closely to the whole cloud native term, you also want to be resilient, right? Resilient in, well, many terms. This, for example, is not really resilient. Depending on your HTTP client, there are some clients that, well, can block a long time until the HTTP connection timeout, well, kicks in. And for some clients, they actually wait infinitely, which is a quite bad idea, because if you can't resolve that, then your thread just blocks forever until you restart the server. So first of all, we want to include some timeouts. And basically, I'm using Java E7 here since well, I want to use Tommy because it's fast, and new application servers hopefully soon will arrive. It just has been out yet. HTTP connection timeout. So actually, what Java E8, what we included in the expert group, was a builder pattern to standardize these connection timeouts. So then you have a nice method, connection timeout and read timeout, and so on and so forth. Connection timeout, let's say we have, well, 100 milliseconds here. So this is now actually a property that is specific for the Tommy CXF client. So in this case, since I'm still using Java E7, I have to use this, well, specific properties. In Java E8, well, you will have a nice standardized builder pattern API. Connection timeout, and the other was I think, read timeout is the name. So here I have it can be quite fast, 100 milliseconds and 2 seconds here. Is it read timeouts? I'm quite sure. Well, anyway, the connection timeout is actually the more interesting thing, because that will break once I cannot do a connection. And just the fact that you will set some timeout here. And then again, a lot of things can go wrong when I read this here with that method below, because, you know, I could not return the response. There could be some other status code, 404, the other application could be down, could send something else. A lot of things can go wrong here. What I can do, well, I could include many things to try and catch something here, but I could also use, well, some Java EE mechanisms to basically, well, pull every failure and be failure safe to return something else, for example, by an interceptor. So what I include, a nice new annotation that I call failure to null, which will be an interceptor binding, and I will include an interceptor that basically does this. Failure to null, which is an interceptor binding. That's it. And I will have an interceptor that tells me, I call this failure to null interceptor, that says if you run this method and anything that goes wrong, just return null in my case. This is of course a very simple example, but well, this is one Java EE mechanism that can handle this. So I want this to be an interceptor, and I will have this interceptor binding failure to null, and I need a priority to include it with application level, so I don't have to configure it in Beans XML, and then basically say object around invoke, that is now interceptor logic. I want to around invoke, I will call this method instead that has an invocation context, and then it says, well, context proceed. That is basically just plainly call that method. And of course, a lot of things can go wrong here since I'm doing an HTTP call. In my case, again, very simple example, just catch anything that can go wrong, catch the exception and do something sophisticated with it, and in my case, just return null. Very simple example that will showcase how to deal with any error here. That's it for that case, and then at least it will not break. It will return null, and I know when jaxRS returns null, then it's 204, no content, and so on and so forth. That's basically it here. So now, again, what do I have to do in order to run this? Well, first of all, I have to compile and build it, right? So I'm rebuilding my WAR file. That's it. There it is. And now, well, I have to rebuild my Docker image, right? I have a new Docker image here, or I want to have a new one, the hello Øredev. I just built that before, and always I said be specific in your version. So now we have a new version. I will rename this to version 2. So we built this hello Øredev there. Done. Well, I also want at some point to pull it later on, so I will push it here. Also done. You see again the power of Java EE and thin deployment artifacts. You're only pushing the last layer on the top, which is like 4 kilobyte, or now maybe 8 kilobyte or something like that. And yeah, 7 kilobyte. And not the 300 megabyte of other data we do not want to push. Only my application changed. The runtime didn't change. And now, well, if I ask Kubernetes, there is still the old pod, of course. Now, what do we have to do in order to redeploy this? Well, we have to go to our YAML file and basically update it, right? Because it still says, if you're running this, please use the image 1. And now it's actually the image 2. And we specify everything as code. We could also specify and just invoke Kubernetes commands on the command line to say, change the image to 2. But this is a bad idea. Why? Because infrastructure as code. Everything we do, everything we specify on our running environment should be specified here as code in our project. So therefore, we actually want to specify it here and then just apply the change to our Kubernetes cluster. That basically means once I say Kubernetes apply for this, then it will see and detect the change there. Kubernetes can resolve all the changes because it still has the resource from the originally generated YAML, and then see, oh, now the image is different. Okay, nice. Then I will just redeploy to that image. And it will do so, and that is now the nice story about Kubernetes, in a production-ready way. So Kubernetes has been built by Google originally, and it was always built to, well, run their workload on their server in a production-ready way. That now means if we want to redeploy it, Kubernetes will do so with ideally a zero downtime deployment approach. So our application is still there. I can show you that with curl hello Øredev. It's still running here. And well, if I redeploy it, then I could have some downtime, right? No, actually, Kubernetes will take care of that, so I can redeploy it with a zero downtime approach. And I can show you this with some basic shell hacking scripting. Every second, call this HTTP method. Hello Øredev, and so on and so forth. And at the same time, we can have a look at the resources, at the pods, so I can explain to you what that is doing. So every second this will update. Now the running pods, there is no update yet. But once I execute this command, what it does, it sees, hey, new image, so I will start up a new pod. You see that? There is no change yet. Why? Because it takes 1, 2, 3 seconds to start it up. And once the liveness and readiness probes check if that is running, then it will change to ready. And then it will say, oh, connection reset by peer. Why is that? Did I change the... Oh, I didn't change anything in the hello Øredev. So basically, that can occur for the proxy server that is up front here locally. But, well, I should have changed something in the code so you see it. So this is now already the new version, but you don't see any change. That was a bad idea. Let's do this again so you see the nice example of not the Øredev greetings, but the hello Øredev. Let's include some change here. Hello Øredev with the, let's say, some timestamp. Otherwise, well, instant now. Otherwise, you don't see any change. That's boring. So what we can do, I now added some change. We can rebuild it over there. So I have a new WAR file there, right? And then I have a new Docker build 3. I push this, right? It's now a little bit squeezed, it doesn't matter. I built it a new image and I pushed it, already done. My change is already in the Docker image. Now what do I have to do? Well, I have to specify for Kubernetes that this has been changed as well. So the new image, and then same story as before. I say, please apply that. And now it will also do this without affecting the other one. So that is, zero downtime approach. That the other one, you didn't see the change before, but that's now the old one is still running until that has been created and is running there. So that is the new version. Error image pull. Did I push it? Hello Øredev. 3, yes. Yeah. Now it's there. Now it's running, and now it's waiting until the application server has been started up. And once it's ready, it will do the switch again and tell us then, well, hello Øredev with some timestamp. If that. Oh, that's good. That's a nice thing about live coding. Anything can go wrong. But actually, that's quite interesting because, guess what? This will happen to you as well once you use it in production. So what can we do in this case? For example, look into the log, look into the output. The output is somewhere here in this container. So maybe I, cannot program and I did something wrong. Let's look into the log files here. What does the log do from this hello Øredev? It will show me the log file from a pod. That is, of course, my running Tommy server here. So I can look into this and it doesn't tell me any exception, right? This looks quite normal. Can do this a little bit smaller so we actually see something, but it says, hey, startup, and it initialized our app, right? Deployed application, no. Did we include the latest application there? That's a good question. Otherwise, maybe it's not there yet. So nothing is wrong. Nothing is run in there, probably. Hello Øredev 3. Let's look into the Docker file. That's still hello Øredev. Okay, let's rebuild it again so we see what is wrong here actually. And this is how we basically can troubleshoot these things. So what options do you have in Kubernetes? Well, you can look into the log files from the container. You can also actually SSH into the container by starting a terminal there. I can show this as well. Hello Øredev. All right, let's Docker build this with localhost and then hello Øredev. Now version, let's just build version 4 and then push this. Yep, now it's there. That's fine. And now we can update this here as well, saying hello Øredev version 4 now please. And apply this again. And then it will, create a container and start it up again. And that means can hopefully, yeah, now that's interesting. Now it's running there, so maybe there was it took some more time to initialize, but that's interesting. I think somehow my Kubernetes cluster is behaving weirdly. Well, the Minikube with all this, so the different story here is the proxy is different because I'm using these IP address that you see to connect. So that is not the proxy you would use in production. But again, all the other things behave in the same way. So anyway, you saw how that is working. You always start up a second container or second pod and leave the other one until the new one is ready to serve some traffic, and only then you do the switch. And then you don't have any downtime. Well, if you use it correctly, not like I'm doing. And, well, now what can we do? We can use now the example with, where is it, curl? Hello, you just saw that, and now hello Duke. It will, in this case, tell us 200 with an empty response, really? Oh, yes, you're right. You're very right. And therefore I, provide an empty string. Please give him a round of applause. He is actually paying attention. I like that. I like participants who pay attention. Yes, you're very right. I'm requesting, well, now an empty Duke, so there's no response here. That means I have an empty string here. In order to get this correct, I have to include the path. So then my path is, actually, let's pretty print this a little bit more. Everything that's in target here, greetings / well, Duke in this case. So nice story is building and redeploying is very fast. We built here with a thin deployment approach. It's already been built. And then Docker build, now version 5, already done. Docker push, version 5. And I just upgrade this. So you see, this is why it's important to have a CI server, because everything there is normally done with my Jenkins. So I don't have to type this all the time. I could use a shell script here. But anyway, it will update here this as well. And then at some point, it will have my new application running there. And then hopefully, till before the session is over, we will have the running example with the second approach. And then, well, while that is updating, I can show you a few other things. For example, there are 2 interesting libraries from Adam Bean, who, well, use this cloud native, this resilient approach a little bit further. Porcupine, that is one library to do some threading in a more sophisticated way using several thread pools that can be configured in Java EE. That is very helpful to do well, pushbacks. What's the name? Bulkheads pattern. And to push that back, and breaker is the other thing, to do a more sophisticated circuit breaker rather than what I did with the 5 minutes interceptor that I included. That did everything for null. This is a little bit more sophisticated, but same idea. It just well, avoids that my application break. And now I have here hello Duke or hello Sweden. And now that is the output that is connected to the second application. And now in, well, my book, I show a lot of other things. For example, I show how to include Prometheus for monitoring there, or how to do configuration, and much more things that we, of course, could not do in 40 minutes in live coding, but maybe you want to have a look into that. And besides that, thank you very much for your attention.